So in the last couple videos, we've discussed derivatives and we've talked about the product rule, the quotient rule, chain rule, etc. So by now we should be familiar with derivatives and taking derivatives of trig functions and composite functions, etc. What I want to do in this video is actually use the derivative and do a very famous application. And essentially what we want to do is we want to find an equation of a tangent line to a curve. So let me show you what that is. So I really like y equals x to the third, so we're just going to work with that curve. So let's say we have, oops, I need to go through the origin. So there we go. So we have y equals x to the third. So let me define it here. We'll call f of x is equal to x to the third. And then we'll say that this curve is f of x. All right. So what we want to do in this video is we want to figure out the equation of the tangent line at x equals 3. Sorry, I'll just write 3 actually. And then because we know this is the x-axis. All right, so we want to find the equation of the tangent line that is right here. So let me draw the tangent line first, and then we'll find the equation. So the tangent line should look something, oh, there we go, first try. Something like that. So again, tangent line means it hits this curve exactly at that point and only at that point. So it does look like it's hitting it here, but if we could graph this completely accurately, it wouldn't. All right, so we want to find the equation of this line. Well, first, let's think about what we need to find an equation of a line. So we know that if we want to find slope-intercept form, we have y equals mx plus b. So in this case, to make this a unique line, we need to find m, which is the slope, and we know how to do that with derivatives, so we'll get to that right now. And we also need b, which is the y-intercept. So it looks like if we extend this line, it hits it at some negative value here. Now, let's think about how we can do that part as well. So let's see what we know here. Well, first of all, we know that this line goes through this point here, because this is the point that they share. And the x-coordinate of that point is 3. And the y-coordinate, well, we can figure that out by plug it into this function, because they share that point. So 3 to the third power is 27. So we know this point is on the line. This is a point on the line. All right, so this is good. We have almost enough information. We either need one more point or we need the slope. In this case, there's no way for us to know another point, so we need to find the slope. And remember, a derivative function gives us the slope at any given point. So let me repeat that one more time. A derivative function gives us the slope of a tangent line to the curve at any given point. So if we take the derivative of this using the power rule, we know that it becomes, so f prime of x becomes 3x squared. And again, what this is the slope of the tangent line at any given point. And that's great for us because we can actually find the slope of this line because we know that this line is at 3. So we simply plug in 3. We get f prime of 3. I'm gonna make it clear that this is equal to m, which is the slope, which is equal to 3 times 3 squared. Well, 3 squared is 9. 9 times 3 is 27. So the slope is 27. So we're actually almost done. Now we need to just find the b value. So let's plug this in. We have y is equal to 27x plus b. And the way we can find this b value is we can use this point that we initially had. We can plug the values in and find our b value. We know that y is 27 when x is 3. So 27 is equal to 27 times 3 plus b. So we can subtract, let's see, 27 times 3, I believe that's 81. So we get 27 minus 81 is equal to b. And therefore, a b is equal to, I don't know, let's see, 81 minus 27. We have 4 there, 5, so 54. So negative 54 is our b value. So our equation of the line, I'm going to write it a different color right here, is y is equal to 27x minus 54. And what this is, again, is the equation of this tangent line right here that is tangent to the curve at x equals